Hey everyone, welcome back to the channel. Today we are diving into a critical aspect of Azure networking, VNet peering. Whether you are working on cloud migrations, designing multi-region architectures, or managing hybrid environments, VNet peering is an indispensable tool in your networking toolkit. In this video, we will break down the architecture of VNet peering, discuss its use cases, and cover some advanced considerations that will help you get the most out of it. Let's jump into it. Let's get started. So, what exactly is VNet peering? At its core, VNet peering allows seamless connectivity between two virtual networks in Azure, regardless of whether they are in the same region or different regions. And the best part, all traffic between the paired VNets stays on Microsoft's private backbone network, meaning no public internet exposure and minimal latency. You can pair VNets across subscriptions, tenants, and even support dual stack configurations IPv4 and IPv6. This makes it highly flexible, allowing businesses to design scalable and secure networks across organizational boundaries. Now let's discuss some of the key benefits of VNet peering. First, it offers low latency and high throughput. The traffic stays within Azure's infrastructure, avoiding public internet, which reduces latency. This is perfect for workloads where performance is critical, whether it's real-time applications or high throughput systems. Secondly, it offers ease of implementation. You don't need extra components like VPN gateways or NAT devices. This cuts down on operational complexity and lets you establish pairing within seconds. Third point is that it offers cross-subscription and cross-tenant connectivity. You can pair VNets across subscription and tenants, making it easier to manage isolated environments, for example, different business units or teams. Lastly, it offers dual stack support. Peering supports both IPv4 and IPv6, ensuring capability with modern networking standards. Now that we have covered the basics, let's talk about use cases where VNet peering shines. The first use case is of hybrid cloud architectures. Often, VNets are isolated by environments such as dev, staging, and production, or even by region for disaster recovery. VNet peering allows these environments to communicate without complexity. The second use case is of multi-region architecture. Do you need to distribute workloads across regions for resilience or load balancing? Global VNet peering can help you achieve this by using Microsoft's backbone network to maintain performance across regions. The third use case is of hub and spoke network architectures. Peering is ideal for hub and spoke architectures, where a central hub VNet contains shared resources like security appliances, while the spoke VNets handle individual workloads. Peering keeps communication efficient and secure. Before jumping into VNet peering, there are some prerequisites to keep in mind. First, VNets must have a unique IP address spaces to avoid conflict. If they overlap, peering won't work. Secondly, you will need the right RBAC permissions, specifically the network contributor role, to configure peering. Make sure the correct permissions are granted for both ends of the peering connection. Lastly, creating or modifying a peering relationship won't cause downtime, but it does automatically modify the routing tables in both VNets. Traffic will be routed through the paired connection without disruption. Even though VNet peering is a simple concept, There are few advanced considerations to take into account. First, Azure recently made it possible to modify the address spaces of paired VNets without breaking the connection. This is a great feature for growing organizations. Secondly, one key limitation is the lack of transitive routing. Traffic doesn't automatically flow between VNets unless they are directly paired. If you need communication between multiple VNets, you will need to create a full mesh or use a network virtual appliance (NVA) to manage routing. Lastly, despite pairing, you still have full control over traffic flow using network security group (NSGs). You can block or restrict traffic between subnets within paired VNets to maintain granular control over your network. To put this into perspective, let's imagine a scenario where you have three VNets: core service, engineering, and research. Core services is paired with engineering, and engineering is paired with research. Without direct pairing between core services and research, traffic won't flow between them. If direct communication is needed, you'll have to set up a full mesh by pairing core services and research directly. Alternatively, deploying an NVA can handle the traffic between VNets that aren't directly paired. While this adds complexity, it scales better for large environments and help overcome the limit of 500 peering connections per VNet. So in conclusion, VNet peering is an essential feature for connecting Azure VNets in a secure, scalable, and low latency manner. Whether you are architecting a multi-region network or building hybrid cloud infrastructures, understanding the nuances of VNet peering is crucial for creating high performance and resilient systems. If you found this video helpful, don't forget to like and subscribe to the channel for more insights into cloud architecture and DevOps. I regularly post deep dives on architecture best practices, so hit that notification bell to stay updated. Thanks for watching, and I'll see you in the next one.